Hi guys, good morning. Welcome back. Today, this is Dr. Sajja Suneel from Data Science Department, Aeronautical Engineering College. Today, I'm here to discuss you about IoT and machine M2M, which is Internet of Things and Machine to Machine. In this particular module, today we are discussing about SDN as well as NFVs. What actually SDN was and what actually NFVs are. SDN stands for Software Defined Network and NFV stands for Network Function Virtualization. These are the two different things which are going to support our IoT system as well as machine to machine systems in our IoT, principles of IoT, which is Internet of Things. And in this Internet of Things, every level will states as a particular IoT system. Level 1, for example, state which states about home automation system. Level 2 which states about smart cities. In similar way, multiple 6 levels which are already discussed in the previous videos. And today I am going to discuss about SDNs as well as NFVs, which is software defined networks and network function virtualization. From these two topics, today we are going to discuss how SDNs are going to support us, what are the different key elements which are existed, and how this SDN network is supporting our IoT system. In the same similar way, network function virtualization. Network function virtualization is the thing where we are from the data which is gathered by the IoT devices, that particular data is going to be virtualized by using the network function virtualization only. And how these two are going to support our IoT systems, today we'll have a look. Let's go into the topic by not wasting the time. See, as I told you from the starting onwards, this particular course, Internet of Things, which is the principles of IoT, which is going to provide us a better understanding about the particular fundamentals, about the technologies, and also the applications which are related to our Internet of Things. And by this course, here the students are going to explore different kinds of principles which are underlying in this particular IoT, along with their architecture and how networking structure was, and also how sensors are going to function, and how actuators are going to function, and how we are providing the integrity and security in this particular IoT system, and also the emerging trends which are evolved in day-to-day life as per the environment. And have a look. And in this module, as I told you, in this particular unit, which is IoT networks and management, today we are going to discuss about IoT and M2M. I already told you IoT stands for Internet of Things and M2M stands for machine to machine. In this, today we are discussing about SDN and network function virtualization. SDN and NFV. These are the two topics which we are going to discuss today. What SDN was and what NFV was, and what are the key elements which are exist in SDN, and what are the key elements which are existent in NFV. And also we are going to discuss about the differentiation between SDN as well as NFV networks which are utilized in our Internet of Things. Let have a view what exactly the things which we are going to do. As I told you, today we are starting with software defined networks, network function virtualization, as well as the differentiation between SDN as well as network function virtualization in our IoT. And from this particular topics, which what we are going to learn, we are going to check out the things such as how the connectivity is going to be in this particular IoT systems, by the help of this network function virtualization. And also we are able to see how secure the communication as well as how secure the data management in between the software defined network as well as this particular network function virtualization, and we are able to provide the security. And from this particular topic the students are going able to know how the structure of SDN was and how the structure of network function virtualization was. And also along with this they are knowing the key elements which are presented in both SDN as well as this NFV, along with the flow control, how the flow control will be there in SDN, how the flow control will be there in this NFVs. All the things are going to be discussed today. And first we will start with discussing about software defined network, which is SDN. SDN in IoT. As I told you, IoT is Internet of Things, which is another synonym. Internet is everything. And here, this particular SDN stands for Software Defined Network, which is a network architecture which is going to separate the control plane from the data plane. And also, it is going to centralize the network controller. Let me explain with the same thing with an example. For suppose we are having an IoT system which is existed. Take an example, your particular classroom is equipped with a particular IoT system, and the devices which are presented in your classroom such as smart lights, smart fans as well as smart cameras and smart attendance monitoring system and the smart electronic gadget which is acting as a projector in your classroom. For all these devices there is a particular network controller which is taken care, and that was the controller which is officially going to separate the exchange the data which is from the control plane from the data plane, that centralizes by using this network controller. And here this particular software defined network controller is going to maintain a unified view means a centralized unique view is going to be presented to you with the help of network. And also this particular software defined network is capable of configuring the smart fan, configuring the smart light, configuring the smart camera which is existed in that particular IoT system. Why configuration is required? Why management is required? Why can't we have to do without controlling, without management? Can't the IoT devices are going to work? Yes, the IoT devices are going to function as per the configuration which is designed by the IoT developer. Developer was the person who is configuring these devices, how they have to act, how they have to capture the data, and how the data has to be transferred with the help of this particular network controller. It is going to provide you a unified view through the network, and it also makes us better comfortability and at the time of configuration and at the time of management. And it also making us a simplest way with these particular things. Why configuration is required for a particular IoT device? With the configuration only that particular IoT device is knowing that this has to be done. For suppose take an example, a particular surveillance camera which is placed in your classroom. If there is no kind of motion detected in that particular classroom, is there any uses of the data which is going to be recorded? No, right? For that particular purpose only, in that particular device we have placed a particular sensor in it which is going to identify the motions which are presented in that particular classroom. If there is no motion detected, automatically after certain seconds of time the particular device is going to switch off, or else it is going to be standby for time being. Whenever a motion is detected in front of that camera, even it is a flyby, the sensor is going to detect that flyby and start recording the process. This is how we are configuring that particular surveillance camera. Like that, every device is going to be configured by you. And also this management is the thing where all the devices which are placed in that particular smart classroom are going to be managed by providing. Why management is required? For suppose I want to access a specific camera, or else I want to access a specific smart fan, or else I want to access a specific light by sitting anywhere in the organization. With the help of that application, I can switch on the fans, I can switch off the lights, smart lights, I can switch on the surveillance cameras, and I can switch on the smart mic, and I want to communicate with you. All these things can be done with the help of this management only. And this particular software defined network was an underlying infrastructure which is going to use a simple packet of data transmission from the hardware. And this is a specialized hardware which is designed for conventional networks. For that purpose only, this SDN network is going to be used, software defined network. In this software defined network, there are some key elements which are presented. And what are those key elements? There are 4 different types of key elements which are presented in SDN. The first one is centralized network controller, and the second one is programmable open API, and the third one is standard communication interface, which is an open flow, and the fourth one is which is open flow, as I told you. And let's have a view how these 3 things are going to support this particular SDN network. SDN, as I told you, it is a software defined network, and this network, in this network, the first one which I told you was centralized network controller. Why a centralized network controller has to be placed in this particular SDN? If there is no controller, how we people are going to communicate with that particular IoT device, right? With the help of this centralized network controller only, we are decoupling the controls from the data plans, and also centralizing a particular network controller which is going to administrate, which is going to configure through the network. If I want to configure a particular surveillance camera, through the network itself I can configure, if I am having this particular network controller, centralized network controller. And coming to the second key element was programmable open API. In this programmable open API, APIs are application programming interfaces, which we discussed in the earlier video. And coming to these APIs, the APIs are going to act as an interface between the application which is designed to control this particular IoT system. For that particular purpose only, this programmable open application programming interface is designed in this particular SDN architecture to support programmable open APIs with the help of that application, and also the control layers. Control layers are nothing but northbound interfaces, and there are some southbound interfaces also. Northbound and southbound interfaces. Northbound interfaces are nothing but the control layers, whereas the southbound interfaces are the infrastructure layers. These infrastructure layers are going to be presented in the next element, which is standard communication interface. This standard communication interface is going to place between the control and infrastructure layers, whereas this particular programmable API is placed in between software defined network application and control layers. You got it? SDN application and control layers. In between that, we faced an interface here, which is programmable open interface, POI. Whereas in between the control and infrastructure layers, we are placing SCIs, which is standard communication interface. These are the key elements which are presented in SDN, software defined network. And along with these key elements, I just want to say one particular thing, which is open flow. This particular open flow is defined by the Open Network Foundation, ONF. This particular Open Network Foundation is broadly accepted by the Software Defined Network Protocol to established for the southbound interface. For that purpose only, this open flow is designed. See here, these are the 3 key elements which are presented in software defined network. The first one is centralized network controller, and the second one is programmable open APIs, and the third one is standard communication interface. These are the three different kinds of key elements which are presented in software defined network. And have a look how this open flow is maintained in form of a switch. If there is a switch, by using this open flow, how the SDN scenario is going to be shown. I'm explaining you with the form of a diagram. See here, this entire scenario, this particular table which is shown here, it is an open flow switch. In this open flow switch, it consists of two different flow tables. This flow table consists of what kind of data has to be transferred from one to other particular device, and this will be in the form of pipeline. And also here we are having a group table. Multiple flow tables are grouped together, then it will be called as a group table. And also we will maintain a open flow channel in this particular open flow switch. Why? Because open flow channel was the thing which is going to communicate with SDN controller with the help of a open flow protocol. SDN controller, as I told you, SDN controller was the thing which is going to configure, which is going to manage, and which is making us that particular IoT system more easier. For that particular purpose only, software defined network controller is going to be established, and that particular controller is going to interact with a protocol by using this particular open flow switch. And have a look what exactly open flow table was. As I told you, in the particular open flow switch, I have shown you these flow tables. How these flow tables internally works, in the next diagram I have clearly specified. Here the flow table consists of three different things: rule, action, stats. What kind of rule is applicable for that particular type of data, and what kind of action is going to be performed, and what kind of status it was. First, either the rule is going to be depends on switch port. You guys well known about what kind of switch port it was. Either the switch port is 1, 2, 3, like that. It depends on the switch capability. There are going to be for 16 port switch, 32, as well as 48, as well as 52, like that. Multiple kinds of switch port scenarios was there. What kind of switch port it was? What kind of MAC source it was? What kind of MAC destination it was? What kind of Ethernet type was it was? Either the Ethernet cable is 5, Ethernet cable is 6, what kind of type it was? And also virtual LAN ID, what kind of virtual LAN ID it was using? And also the IP source, IP destination, internet protocol source, internet protocol destination, internet protocol pro routing. And also there are two different protocols which we are using, such as transmission control protocol and user datagram protocol. Here in this rule we are using two different things: TCP S port and TCP D port. S port is nothing but the source port, and D port is nothing but the destination port. In rule, these are the things which has to be kept at. And coming to action, how the data is going to be transferred, either in a forward packet to the particular port, or encapsulate and forward it to the controller, or else we are going to drop the packet, or else we are sending it to a normal processing pipeline. These are the four different kinds of actions which are going to be performed in that particular flow table. Coming to the third phase, which is the status, what kind of information it is packing? It is taking a particular packet with a set of particular byte counters. This is how internally the flow table will consisted. Once again, what are the three different things which flow table is going to maintain? One is rule, another one is action, another one is status. In rule, it is going to keep the different kinds of things, information which is going to be utilized. Either we are using virtualized LAN ID, either we are using TCP source port or destination port, or we are using IP source, IP destination, or IPP routing, or else we are using any kind of Ethernet type, or else we are using any kind of MAC source or MAC destination, or else we are using the particular switch port number. These are the things which are existed in rule. Coming to action, in this action we are using four different kinds of action. The first action is forward packet to count, and the second action is either we are encapsulating and forwarding the controller, and the third one is we are dropping the packet, and the final one is speed to normal processing pipeline. These are the four different kinds of actions which are going to be taken. And coming to the status, we are showing what kind of packet we are using and what kind of information, how much information, either it consists of bytes, bits, like that. And have a look what next topic, as I told you, that is up to SDN. Now we are entering into a new topic, which is network function virtualization. How this network function virtualization is going to function, what network function virtualization was. Network function virtualization, it is a technology which is going to virtualize for consolidating the heterogeneous network devices into the industry standard high volume servers by using switches and for storage purposes. For suppose, take an example. In our organization, there was a heterogeneous network devices. For suppose our organization is enhanced to university, then our standard of servers are going to be enhanced, then our standard of switches are going to be enhanced, our storage capacity has to be enhanced. For that particular purpose, from SDV to now we are moving towards network function virtualization. This was the technology which is going to leverage your virtualization to consolidating this existing heterogeneous network devices into industry standard virtualization by making high volume servers and high volume switches and high volume storage devices. And see here, along with the NFV, it is a complementary to SDV. As I told you, NFV was the technology which is providing us an infrastructure where we can run it on SDN also. These two are mutually beneficial to each other, but they are not dependent. What two are mutually beneficial to each other? NFV, network function virtualization, and software defined network are mutually beneficial, but these two are not going to be depends on each other. Now we'll have a look about the diagram, which is network function virtualizer, and have a look how the things are. These are the virtualization network functions which are going to be executed, and there is a network function virtualization infrastructure, and there is a virtualization layer, and there is a network function virtualization management and abstraction. We are knowing about these four different things in detail in the coming slides, and have a look how the scenarios has been established. In the top performance, we have set it multiple virtualized network functions, whereas in infrastructure, either it is virtual compute, or it is virtual network, or it is virtual storage. These are the three things. These are the three things which are kept in infrastructure, and in between the infrastructure and the type of action which we perform, either we are going to commute, either we are going to use network, either we are going to use storage. In between these two, there is a virtualization layer which is established. For suppose from storage I am retrieving some kind of information, that can be retrieved with the help of this virtualization layer, and it can be communicated with the virtualized storage, and it can be transferred to the virtualized function. Whereas in NFV management and orchestration, in this network function virtualization, the things are going to be managed in a effective way. And have a look, I already told you these are going to be beneficial. What are the key elements which are existed in this network function virtualization? The first key element was virtualized network function. What virtualized network function was? Basically, it was a software implementation of network where the function is capable of running over the infrastructure. For that particular purpose only, it was clearly specified as network function virtualization interface. That was the interface which is acting in between this virtualized network function as well as the other scenarios. What kind of infrastructure it was providing? Infrastructure is nothing but either the by using our IoT system with the help of this NFVs, network function virtualizers, what people are capable of. Either the user is going to compute the things, either the user is going to utilize the network, either the user is going to utilize the storage resources which are virtualized here with the help of the open flow. These are the two different key elements. Along with this, The other key element was network function management and ostrich. This was the area which is going to focus particularly on virtualization specific management, where whatever the tasks which are issued to that particular IoT systems is going to cover the artisan as well as the life cycle management of physical RLs. These particular software resources are going to be utilized by the software virtualization by based on our life cycle managements of virtualized network functions. How these life cycles are going to be dependent on. For suppose we have seen multiple IoT levels. In those levels, there are multiple kinds of IoT systems. These particular things are going to be discussed in detail at the time of this network function virtualization. Why? Because every system is having multiple devices in it. With the help of this network function virtualization, whenever the system is expanding, it means initially, for suppose, take an example, you have constructed a small house. In this small house, you are having a small IoT home automation system. For suppose in future, or the home is going to be in a similar same way, or as per your growth, you are going to change your home automation system also. Initially, you are only using for smart lights and smart fans, or else for controlling the gadgets which are presented in your home. In future, or it is going to be in the same similar way, no, right? The things are going to be extended apart our level. Why? Because in initial days IoT was a small part thing, and in this current scenario, everywhere, in every organization, every industry, whatever it was, you name it, our IoT is ready to serve in part of this particular uh, industry requirement. For that particular purpose only, these are the NFVs, network function virtualizers, which are going to help us for making the things in a better way. And this was the virtualizator which is going to separate our network functions which are implemented from the softwares. Why? Because software defined network was the thing which is defined by the software, whereas network function virtualizer was the thing which is managed by network management and orchestration. And here the network functions which can be easily tested, as well as we are going to upgrade it with the set of installments which are made in the hardware. See here how a conventional home network architecture was set up in the public network. See here, this was the home network, whereas this was a public network. How the public network was? There is a service provider. Take an example, Airtel. Take an example, Airtel. Airtel has placed as a public network. Here there are multiple routers which are connected with internet, IPTV and voice internet protocol. Like that, multiple things are connected in the public network. For that, he is providing service to the home gateway. From this gateway, all are interconnected to all the IoT devices which are existed in our house. As I told you, it was a conventional home network automation system. In this home network automation system, this was the architecture how physically it is going to be. For this particular router, IPTV, voice internet protocol phone, laptops, tablets, smartphones, etc., and your single board computer which is connected with lights, fans, doors and multiple sensors which are placed, and also it is connected with smart washer, and also it is connected with smart refrigerator. Smart refrigerator, in every electronic gadget there is an embedded system which was clearly faced in this smart washer. You are seeing an LED. Behind that LED there was an embedded system which is configured by that particular IoT developer. In smart refrigerator also there will be electronic embedded system which is configured. And if you see all the lights, doors, windows, smart fans, everything which is connected with this particular single board computer which is linked with our network, as well as laptops, tablets, smartphones, which is internally there will be a embedded system. And in voice internet protocol phone there will be an embedded system. And IPTV, internet protocol television is also having an embedded system. This was the convolutional home network architecture, which is supported by our network function virtualization. See here, in case if we use a particular use case which is implemented by using our network function virtualization. See here how the things are. If we use in the public network how a virtualized home gateway and how an infrastructure is inherited in the same particular architecture. What was the difference here? Instead of multiple public networks, we are using a virtualized home gateway and network function virtualization infrastructure. Instead of those particular things, we are utilizing this particular use case here, and we are connecting with the wireless access point layer 2 devices. I just want to show the difference between these two diagrams. If you observe carefully here in this public network, these are the things which are placed. Whereas if I use network function virtualization, I need to place two different things, which is done in this particular use case was virtualized home gateway and network function virtualization infrastructure. This was the difference which is shown in our home automation architecture. And what are the different key elements which are presented in this particular network function virtualization? This can be used by virtualizing our home gateway. And what home gateway is doing? Here the home gateway is going to perform different kinds of functions, which includes DHCP, control protocol server, which is a dynamic path, and also the network address translation, which is going to translate the address by using the network, and also application specific gateway and firewall. These are the four things which we are going to be utilized by our home gateway protocol. And also this network function virtualization infrastructure in our cloud, it is virtualized by using a particular hotway. Depends on DHCP server, or else it can depend on network address translation, or else it depends on application specific gateway, or else by basing on firewall for providing security in the network function virtualization. And where this NFV is going to host, this NFV infrastructure is presented in cloud with a virtualized home gateway. That gateway is going to be consist of three parts: DHCP server, network address translator, and address specific gateway and firewall, which is going to take care of security. And this particular virtualized gateway is going to deal with your private IP addresses which are connected with your home. And also the gateway is also connected to a network such as voice internet protocol, phones and TVs, or the things which are connected with this particular network function virtualizations. And have a look why these SDNs and why these NFVs are needed for our particular IoT system management for a better configuration and automatic configuration. Automatic was the thing where we are configuring the system which is going to ensure all the devices will have the same kind of configuration, and also different kinds of variations, and also there will be a chance of multiple errors which are going to arise, which are going to be avoided with this particular configuration. Automatic configuration, the best example which we already discussed. Once again I am bringing that example to you for your better understanding of automatic configuration. Everyone are using smartphones nowadays, right? In your smartphone, are we getting any kind of software update to your concerned gadget or not? With a minimal human intervention, that update is going to be done in your electronic gadget, and it is going to bring back multiple features which are advanced when you compare to the previous scenario, and the visualization is going to be changed. That is what automatic configuration was. And the second thing was monitoring operational and statistical data. In the same kind of example, the same electronic device which we are using, smartphone. In this smartphone, are the things are going to be monitored behind the app or not? How much time we have utilized? This app has been utilized this much of internet connectivity, the entire things. We are monitoring both operational as well as the statistical data. For that purpose only we are utilizing this particular thing in our IoT system, and also which is going to improve the reliability. By using this particular NFVs, the reliability is going to be increased, and also system wide configurations and multiple system configurations are going to be known to us whenever we are utilizing a network function virtualization. With the help of this, we are retrieving and reusing multiple different types of configurations in your thing. These are the particular needs which are we have required in our IoT system management. See here how we are managing a device with simple network simple network messaging protocol by using SNMP, simple network messaging protocol. And by using this SNMP, how the this was the user. For suppose treat us and treat me as an user, I am forwarding a mail to all my students. In between, what was the thing happening, how I am managing that particular agent. I was connected with a network management station, which is, you can consider it as Airtel. I'm using Airtel network, so you can consider me as a network management station was Airtel, and that station is going to have a communication with the managed device, who is simple network messaging protocol agent, whereas management information base which he is having. By depends on that, if the message is going to be delivered to the destination. And have a look, with the help of this simple network messaging protocol, which is well known to you in form of emails, right? And it is a widely used network management protocol which is going to allow us for monitoring and for configuring the networks such as routers, switches, servers, printers, etc. And this SNMP component is going to include with NMS, network management station, managed devices and managed information bases, and also an agent will be there which is placed to run on a specific device. These are the components which are included in SNMP, simple network management protocol. That these are the things which are included. And what are the different kinds of limitations which are set it down in SNMP? SNMP, as I told you, simple network message protocol, which is a stateless protocol in nature, but this protocol is going to request you for containing whatever the information in form of a request, and also that particular application need to be an intelligent for managing the device. As I told you, it is a stateless, it is a connectionless protocol which is used by UDP as a transport protocol. For making transmission, we are using UDP, user datagram protocol, and here there is no support for acknowledgement. As you guys know, only transmission control protocol is the protocol which is going to give you handshake. In user datagram protocol there will be no handshake, as it is a wireless network. And coming to message information base, which is often lack with multiple objects whenever we are configuring in the network by using this SNMP. These are the limitations which are set out for simple network messaging protocol. And have a look, what are the things which are there for MIBs, messaging information base. It is the thing which is used difficultly to configure between the configuration and the state data which are presented in our MIBs, and also we are able to retrieve the current configuration of a specific device, and also that the same device earlier configurations do not have strong security features whenever an auto configuration is updated. Early versions doesn't have security. Why? Because compared to the advanced version, early versions are a little bit secure. These are the things which are presented in the limitations of SNMP. And what kind of network operators are required? The networks operators must be easy to use, and distinction between configuration and stating the data. We need to fetch configuration and state the data separately. Why? Because whenever we are fetching data for execution, it has to be fetched separately, and also we need to state the data separately. Whenever we are doing a configuration in a network as a whole, thing, the configuration has to be done. For the entire transaction through the devices, the configuration has to be done. The details has to be maintained, and also you need to dump and restore the configurations whenever you required. Along with that, in this configuration database schemas, we need to compare the different kinds of configurations at the time of this particular network operator. Why comparison is required? Whether that one is good means if we are going to use that configuration, which kind of configuration is suitable to that particular device, that kind of configuration has to be utilized by us for a better quality, right? And have a look, role based access control, consistency in access control is, and also multiple configuration settings. These are the things, and along with that we are going to support for both data oriented as well as task oriented. What was the difference between data oriented and what was the difference between task oriented? Data oriented was the thing where we are gathering different kinds of information, whereas task oriented, by based on that particular data we are performing some particular task. Take an example, real time example. You are doing an experiment. For doing that experiment, what was the basic need? You are gathering some information which is data oriented. Whenever you are performing the experiment, then it is a task oriented. That was the difference. This particular NFV is going to support both the purposes. And that's it, guys. I'll meet in the next class with another session by based on this particular IoT and MTM. That's it for the day. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.